We are Team Atbash Tiffins, and composed of Anirudh Jayakumar, Chet Johal, myself Dylan Danno, and Yong-Gyum. We have decided to take on the problem of the bridges of Konigsberg. Konigsberg, now called Kaliningrad, was once a thriving German town in eastern Prussia, built around the river Pregel. It was a popular challenge in 18th century Konigsberg to attempt to go on a walk, starting and ending at any point, which crossed the 7 bridges that stretched across the river exactly once each. However, no matter how hard they tried, the locals just couldn't manage to do it. Stumped, in 1735 they asked the famous mathematician Leonhard Euler for help. He realized that, to solve this problem, he would have to simplify the city of Konigsberg into a basic diagram. He did it like this. He realized that the banks and islands on the river could be simplified into 4 points, like this. From that, lines could be drawn between the points to simulate the bridges, like this. In the end, he was left with a diagram that looked like this. However nice that looks, it doesn't leave us any closer to solving the problem. We can trace out as many routes as we want on it, but we still can't seem to find a solution. It is, in conclusion, impossible. But why? Euler realized that, as every point had to be entered and left by a bridge, with the exception of the start and finish, for the problem to work, every point except 2, the start and finish, needed to have an even number of bridges. However, when we count the number of bridges on the diagram, we find that all the points have an odd number of bridges, with 3 having 3 and 1 having 5. From this, he could mathematically conclude that the walk proposed by the local Konigsbergians was impossible. Euler's work in this field was the beginning of a new area of mathematics called graph theory, which is the study of problems that can be simplified down into graphs made up of points, or vertices, and interconnecting lines, or edges. In honor of his work, a trail that runs through each edge exactly once on a graph is called a Eulerian trail. Euler published his results in an article called Solutio Problematis ad Geometriam Situs Pertinentis, which means the solution of a problem relating to the geometry of position. It was published in 1741. Euler also worked out that, for an object to be a planar graph, a graph on which the edges don't intersect, the graph must have the formula v minus e plus f equals 2. V is the number of vertices or points on the diagram, E is the number of edges or intersecting lines, and F is the number of areas, called faces, that those lines create by intersecting the diagram, including the large outer face. As 4 minus 7 plus 5 equals 2, this problem is a planar graph, as we can see because the lines don't intersect. However, all this didn't really help the people of Konigsberg, who wanted to be able to walk their own Eulerian trail. We could also destroy any bridge to the same effect. But hold back with the dynamite. In 1945, Allied air raids over Konigsberg destroyed these 2 bridges. This left the city with the bridges it has today. As you can see from the map, this has left 2 banks with 2 bridges and 2 banks with 3, which means a Eulerian trail can be formed. We can finally take that theoretical walk that was proposed so many years ago. Okay, so what's the significance of all this, apart from telling us that people can now take a more interesting walk around Kaliningrad? Graph theory is a very useful field of maths, and is used to model a whole bunch of systems, including websites, molecules, migration paths, transport networks, and social structures. As well, Eulerian trails are used to reconstruct DNA sequences from DNA fragments. Pretty neat, huh? Thank you for watching. This has been Team Atbash Tiffins on the bridges of Konigsberg.